Good day. Let me present a scientific research on the topic computer simulation modeling of voice signals in the Matlab environment for the task of computerized diagnostic system testing. According to the statistics of the World Health Organization, the number of people with disorders of the human vocal apparatus is increasing every year. Timely diagnosis makes it possible to detect changes in the functional state of the vocal apparatus organs through proper processing of voice signals and to carry out preventive measures or choose a course of treatment. The effectiveness of the functioning of the diagnostic system is determined to a decisive extent by the methods of voice signals processing, which are the basics of the development of such a system software, and must have the means of extracting informative characteristics of changes in the voice apparatus operation. The most informative in terms of medical diagnostics is the selection and processing of a separate class of voice signals, vocalized fricative sounds, as the most sensitive to changes in the functional state of the vocal apparatus organs. However, in order to test the methods of processing to evaluate the reliability of the results of processing vocalized fricative sounds by methods and accordingly the algorithms and software of diagnosis systems, it is necessary to develop a method of computer simulation modeling of the signal, which would take into account in its structure the main parameters of the medical norm and the pathology of the vocal organs apparatus state, and would make it possible to provide parametric identification on the method of such signals processing in computer diagnosis systems with reliable data reproduction. The process of vocalized fricative sounds creation is shown in Figure 1. Such signal can be represented as a pulse of an amplitude modulated acoustic signal in the form of expression. 1. Pathological changes in the organs of the signal source will be manifested in a change in the time and energy characteristics of the carrier component of signals. Similarly, a dysfunction of the articulation apparatus will be manifested in change in the corresponding characteristic of the invalue component of signal. To determine the time and amplitude characteristics of such components of vocalized fricative sounds, their selection was carried out. Graphs of the envelope component and sample from the carrier component of the signal are shown in Figure 3. At certain intervals, the carrier component of vocalized fricative sounds behaves as a complex mixture of sinusoids, characteristic points and amplitudes of the carrier component of vocalized fricative sounds within one period are shown in Figure 4. We build a model of the carrier components of vocalized fricative sounds signal in the form of a complex mixture of sinusoids, which takes into account the characteristic points and amplitudes of the signal within the period. Let's reduce the system of equations to one expression. In a similar way, we can write down the expression for the envelope component of vocalized fricative sounds. Then computer simulation of the carrier component of the voice signal was carried out in the Matlab environment. In Figure 5 shows the sections of the carrier component of real and simulated signals. It can be seen the high degree of similarity of such signals, but the model must take into account the presence of a random component in vocalized fricative sounds, which depends on external and internal factors and forms of pronunciation disorders. In expressions 3 and 4, the amplitudes of the waves and their time durations are constant values. So we introduce a random component into these expressions. Let's combine expressions 5 and 6 into one, which will be the expression of the simulation model of the vocalized fricative sounds. Using expression 5.7, the results of computer simulation of equalizer fricative sounds with different amplitudes and durations within the normal limits were obtained, which were implemented as a program in the Matlab environment and shown in Figure 6. From Figure 6, it can be seen that the time realizations of the real and simulated signals are similar, and the ratio between the maxima in the power spectral density distributions of these signals, called performance, is preserved, which indicates the suitability of the developed simulation model for testing computer diagnostic systems. Thank you for your attention.